Okay, so now we're finally getting to the part where we're going to verify the trig functions. All right, remember these fundamental trig identities, you have to have these memorized for our quiz on Tuesday of next week. We're going to be going back to these concepts. Remember here we're missing sign and we're missing 3 reciprocal identities. These are also known as quotient identities. We will be using the Pythagorean identities a lot in some of these proofs. When you're working or when you're verifying trig functions, typically I like to work on the left, but you can work on each side of the equation independently of the other side. Okay, so keep that in mind. Notice the word is independent. You're not changing one is equal to something different and creating your new equation. No, you're working on the left, rewriting it. If you need to, go to the right and try to simplify that as well. Start with more complicated side and transform it step by step until it looks exactly like the other side. And you're going to analyze the identity and look for opportunities to apply the fundamental identities that I just showed you. And try using one or more of the following techniques. This is what I was mentioning before. You want to rewrite, if you can, in terms of sine and cosine. Factor out the greatest common factor. Separate a single term quotient into 2 terms, just like this. Combine fractional expressions using the least common denominator. Multiply the numerator and denominator by a binomial factor that appears on the other side of the identity. And don't be afraid to stop and start over again if you're not getting anywhere. It's really important. You might have to, toss out what you did and try a fresh approach. Creative puzzle solvers know that strategies leading to dead ends often provide good problem solving ideas. So let's take a look at some examples. All right, here's the first one. We want to verify the identity cotangent squared x plus cosine squared x is plus sine squared x is equal to cosecant. Okay, so like I just mentioned a moment ago, we want to start on the left because that's the more complicated side. And what we're trying to do is provide a proof that this is in fact equal to cosecant squared x. Well, right off the bat, I noticed that I have a Pythagorean identity right here. So I'm going to rewrite this as cotangent squared x plus 1. Do I have any other trig identities? Yes, this is equal to cosecant. So this one was fairly easy. I just proved that the left does in fact equal the right. And notice that I didn't even have to touch the right. So I just verified it. So what we're trying to do is confirm or provide a proof, a step-by-step proof that the left is equal to the right. And if I have to, I do manipulate the right side, but typically begin with the complicated side and break that down first. Let's take a look at another example. Here it says verify the identity tan squared x minus sine squared equals tan squared times sine squared. Okay, so let's take a look at this. Alright, there's multiple ways to approach these. So even if your mind goes somewhere else to different identity, that's fine. Here, I'm going to rewrite tangent in terms of sine and cosine. Remember, that's one of the steps that I said try to manipulate these things. If you can, write anything in terms of sine and cosine. Tangent is sine over cosine. Sine squared over cosine squared. So right now, I'm working on the left side. And this is minus sine squared x. I'm not going to touch the right side until I have to. That's just my preference. And I'm going to combine these. Remember those little key steps I said? If I have 2 fractional expressions that are separated, I want to bring them into one. So here I have a common denominator is going to be cosine squared x. So I'm going to multiply this by cosine squared x over cosine squared x. And now I'm going to rewrite it. I have sine squared x minus sine squared x times cosine squared x over the common denominator, which we said was cosine squared x. Alright, so that's what we have so far on the left. In the numerator, I can factor out a sine squared x. And I get 1 minus cosine squared x. Always keep in mind where you're trying to go, because right now I can go a few ways, with what I have. But what I'm trying to get to is tangent times sine. So if I'm trying to get to tangent and sine, I'm not going to substitute the sine that I already have here. I'm going to substitute this 1 minus cosine squared, which is a Pythagorean identity. And that Pythagorean identity is sine. Good, sine squared. So we have sine squared x times sine squared x over cosine. And now because all of these are factors, I'm going to break this up. Sine squared over cosine squared times sine squared. And what's sine squared over cosine squared? Tangent squared x. Good. And did I verify the side on the right? Yes, I did. Notice that I did end up with the given, so we verified it. So that is equal to tan squared plus sine squared. Times sine squared. All right, let's take a look at another example. All right, so we have two fractions on the left that we're going to verify to equal sine cosecant. Because I'm trying to get to the product of something, I want to get rid of these two fractions. So I'm going to combine them by getting a common denominator. So the common denominator is take that left fraction, multiply it by secant of x over secant of x. And here we have sine over cosecant plus cosine of x over secant of x is going to be multiplied by cosecant over cosecant. So again, I'm working on the left side, so if you want, I'll put an L for left side, so that way you know. Okay. So now I'm going to combine these fractions. I know that here I'm going to end up with secant over cosecant, and here I have sine. If it helps you, rewrite that secant that I'm going to multiply with that sine as 1 over cosine plus cosine. Remember I said to express everything in terms of sine and cosine? And here cosecant is 1 over sine. So now when I combine the numerators, and I'm going to do the same thing in the denominator too, by the way. Numerators, we end up with sine of x over cosine of x, and then cosine of x over the sine of x. And the same thing in the denominator, just real quick, secant 1 over cosine, and cosecant is 1 over sine. So this ends up as 1 over cosine times sine. Okay. All right. So if you have to pause where you are, take a look at where we're trying to end up at. We're trying to end up with two terms, the product of two terms, sine x times cosecant x. So now let's take a look at where we are now. I have two fractions in my numerator that are being added and a fraction in my denominator. I could potentially end up with a product of two terms if I combine this as a single term. So I need a common denominator. So here I'm going to multiply this by sine over sine. And on the right, I'm going to multiply this by cosine over cosine, so that I do end up with one term in the numerator. So let's rewrite that. I'm going to end up with sine squared x plus cosine squared x over sine times cosine. And we're dividing by what we have in the denominator, 1 over cosine x sine x. And I have something special. What is this? All right, that's right. The numerator is a Pythagorean identity. So that becomes 1. over sine x, cosine x, divided by 1 over cosine x, sine x. So now I'm going to do state change flip. And this is going to equal, just real quick, I'm going to do sine 1 over sine cosine times cosine sine over 1. What happens here, guys? What do I end up with? These are factors, so sines reduce, cosines reduce. I end up with 1, and that's on my left side. So now I have to reevaluate the right side. Remember, I said we're working on both sides. I have to verify that they are in fact equal. So I'm going to go back up here, sine and cosecant. What are they? They're reciprocals. So here I'm working on the right side now. Sine times 1 over sine equals 1. The left does equal to the right. So now we just finished verifying. So notice that I have a proof for the left side and I have a proof for the right side. All of this and this is part of my proof. And notice that I have it labeled where I was working on the left and where I was working on the right. Okay, here's another example. We're going to verify the identity. So again, I'm going to start with the left, the more complicated side. I'm going to label what I'm doing. And right off the bat, I notice that this is a Pythagorean identity. Which one is it? Secant squared. Okay, so let's rewrite it. Cotangent x times secant squared x over tan x. Okay. So what I'm going to do is I'm going to switch my sines and cosines. Cotangent is cosine over sine. Secant is 1 over cosine squared x. And then tangent is sine over cosine. Here, this reduces and I'm left with 1. And I end up with one over sine x cosine x over sine over cosine. State change flip. 1 over sine x cosine x times cosine over sine. My cosines reduce and I'm left with 1 over sine squared x, and the reciprocal of that is cosecant squared x. Notice that I didn't even have to touch the right side. I was able to verify this all just working on the left. Alright, so in this example I am definitely going to start on the right side because when I look at the left, sine over sine plus cosine, tangent just seems easier to manipulate with identities. I can substitute this with a quotient identity and this as well. So let's work on the right side. So the top is going to be sine over cosine, and the bottom is going to be sine over cosine here. And now here, I want a common denominator, so I'm going to switch that up. I have sine over cosine over cosine plus sine over cosine. Now that I have that, I can merge the fractions at the bottom. So I end up with sine over cosine for the numerator over cosine plus sine over cosine. Now I'm going to do state change flip. Sine over cosine times 1, no, not 1, just kidding, cosine over cosine of x plus sine of x. Here my cosines reduce, And I'm left with sine of x in the numerator, cosine of x plus sine of x. And that equals the left side. So in this time, I completely manipulated the right side in order to get it to equal the left side. So I just finished verifying my identity. It's really important to identify which side you're working on when you're showing me your proof.